Good morning or good day, everyone, wherever you are. I see people are just coming in, so just give us a few minutes as we start to populate the webinar, and we'll get going. I see some familiar faces in our room, in our chat. Thank you all for being here. Really appreciate it. See people are still coming in, so just give us one more minute and we'll get started. All right, let's begin. So welcome to the Online Ethics Center Spring 2024 webinar series, Bringing Ethics into the Conversation. My name is Azita Hirsa, and I'm a teaching professor at the Rensselaer Polytechnic Institute School of Engineering, Industrial Systems Engineering Department, where I teach courses in Management of Engineering Technology, Ethics of Modeling, Engineering Ethics, and Professional Development, Technical Issues and Solutions. I'm the chair of the Ethics Division of the American Society of Engineering Education, ASEE, and thrilled to be the webinar host for OEC's 2023-24 season. The Online Ethics Center, hosted at the University of Virginia, is a digital repository for resources on teaching and learning about ethics in engineering and science. The OEC also fosters a community of faculty, students, researchers, and other professionals who come together to discuss ethics. Please check out our website on onlineethics.org. The theme of our fall-spring webinar series is Engineering Ethics in Industry. I'm delighted to host our speaker today, Dr. Arthur Leonard Kaplan. Doctors William F. and Virginia Conley Mitty, professor and founding head of the Division of Medical Ethics at NYU School of Medicine in New York City. Prior to coming to NYU School of Medicine, Dr. Kaplan was the Sidney D. Kaplan Professor of Bioethics at the University of Pennsylvania Perelman School of Medicine in Philadelphia, where he created the Center of Bioethics and the Department of Medical Ethics. Kaplan has also taught at the University of Minnesota, where he founded the Center of Biomedical Ethics, the University of Pittsburgh, and Columbia University. He received his PhD from Columbia University. Dr. Kaplan is the author or editor of 35 books and over 860 papers in peer-reviewed journals. His most recent book are Vaccination Ethics and Policy with Jason Schwartz and Getting to Good, Research Integrity in Biomedicine with Barbara Redmond. He has served on a number of national and international committees, including as the chair of the National Cancer Institute Biobanking Ethics Working Group, chair of the Advisory Committee to the United Nations on Human Cloning, chair of the Advisory Committee to the Department of Health and Human Services on Blood Safety and Availability. He has also served on the Presidential Advisory Committee on Gulf War Illnesses, the Special Advisory Committee to the International Olympic Committee on Genetics and Gene Therapy, the Special Advisory Panel to the National Institute of Mental Health on Human Experimentation on Vulnerable Subjects, the Wellcome Trust Advisory Panel on Research and Humanitarian Crisis, and the co-director of the Joint Council of Europe-United Nations Study on Trafficking in Organs and Body Parts. Dr. Kaplan has served since 2015 as the chairperson of the Compassionate Use Advisory Committee, COMPACT, an independent group of internationally recognized medical expert, bioethicists, and patient representatives, which advises Johnson & Johnson's Janssen Pharmaceutical about requests for compassionate use of some of its investigational medicine. Dr. Kaplan is a regular commentator on bioethics and healthcare issues on WebMD Medscape, WGBH Radio in Boston, WOR Radio in New York City, and KNX CBS Radio Los Angeles. He appears frequently as a guest and commentator on various other national and international media outlets. Kaplan is the recipient of many awards and honors, including McGovern Medal of American Medical Writers Association and the Franklin Award for the City of Philadelphia. He was a USA Today 2001 Person of the Year and was described as one of the 10 most influential people in science by Discover magazine in 2008. He has also been honored as one of the 50 most influential people in American healthcare by Modern Healthcare magazine, one of the 10 most influential people in America in biotechnology by the National Journal, one of the 10 most influential people in the ethics of biotechnology by the editors of Nature Biotechnology, and one of the 100 most influential people in biotechnology by Scientific American magazine. During the COVID-19 pandemic, he co-directed an advisory group on sports and recreation for the U.S. Conference of Mayors, created a national working group on coronavirus vaccine challenge studies, developed an ethical framework for distributing drugs and vaccines for J&J, helped develop rationing policies for NYU, LMC, and many other health systems, was a member of the WHO Advisory Committee on COVID, Ethics, and Experimental Drugs and Vaccines, and helped set policy for WIRB, WCG for research studies. He was an advisor to the Moderna Accenture, and he continues to serve on the NCAA Sports and COVID Committee. He received the Patricia Price Brown Prize in the Biomedical Ethics for 2011. In 2014, he was selected to receive the Public Service Awards from the National Science Foundation and a National Science Board, which honors individuals and groups that have made substantial contributions to increasing public understanding of science and engineering in the United States. In 2016, the National Organization for Rare Disorders, NORD, honored him with the Rare Impact Award and Food and Drug Law Institute's Distinguished Service Leadership Award. In 2019, he was honored by the FDA's Reagan-Udall Foundation with its Innovation Award, NYU Rory Myers College of Nursing Humanitarian Award. He holds 7 honorary degrees from colleges and medical schools. After Dr. Kaplan's talk, we will take questions. To ask a question, please type in the Q&A box at the bottom of your screen rather than the chat box, and I will read it to him. Audience members will not be able to use their mics and cameras. It's an absolute honor and a pleasure to be in the space with you, Dr. Kaplan. So the mic is yours.
Thanks, Azita. I'm going to do this talk in 2 parts. First, no slides. I'm going to tell you about the history of organ transplantation with an ethics angle. Second, I'll get to the use of animals, particularly pigs, as potential sources of organs and the issues that raises, which is one of the big bioengineering activities going on in the United States today, efforts to try and engineer animals so that they can be used as sources of organs, and I'll tell you about that later. But just to set the context, the first successful organ transplant was done by a doctor named Joe Murray. He had watched skin grafting efforts during World War II. He was at the U.S. Army Defense Department Hospital at Valley Forge, and he'd seen different people who were burned, had burn injuries, get skin grafts. Those grafts didn't linger, but they did provide enough time for the person's own skin to grow back. So he was very alert to the possibility of transplanting tissues. When he got to Boston, he continued animal work, thinking maybe you could transplant kidneys. That turned out to be pretty hard. He didn't have bioengineering help in this because he was trying to do it surgically, but didn't have the immunosuppressants, the chemicals needed to shut off the recipient's immune system, which immediately will attack transplanted tissue as foreign, seeing it as a life-threatening microbe. Nonetheless, one day he got approached by a 22-year-old individual who'd been in the Coast Guard but had been discharged because of kidney failure. Another piece of bioengineering that did not exist in 1953 was kidney dialysis. So there was nothing to give this young man, Richard Herrick. He was going to die when his kidney stopped working, and we didn't have any machine that could clean the blood. That's what kidney dialysis does. So Murray thought about it and said, well, who might donate an organ to? And it turned out Richard Herrick had a twin brother. So they knew they would get past, or they thought they would, the biology limits of putting different tissues in. And indeed, they went to the brother and he said, sure, I'll donate a kidney. I've got two, I'll give one. Herrick got the kidney. He went on to live with that kidney another 8 years. By the way, he also married one of his nurses who he met during the procedure, which was just gossip from the history of transplant. And he had 2 children with her. And it was the first successful organ transplant done at the Brigham Hospital in Boston in 1954. There were objections raised ethically to that first successful transplant. One was, it's wrong to harm somebody in order to help somebody else. It's one thing for you maybe to sign up for a risky experiment if you have cancer. It's one thing to sign your child up for an experiment if they have different conditions like Tay-Sachs or sickle cell and you're trying new drugs, you may be trying out a new vaccine. But the risk is going to be borne by the person who gets the benefit. In the case of the Herrick transplant, you harmed somebody by taking out a kidney and gave it to somebody else who benefited, but you were making the donor worse off. So many people raised issues about that. No bioethicist, there wasn't any bioethics in 1954, but different people were critical. There was also a worry that you were making money by harming someone, so that you were profiteering by saying, I'm going to be a doctor who takes organs out of people, gets paid to put them in somebody else. Actually, the Pope at that time raised that objection. So things didn't start off just with celebrations. Dr. Murray himself said he had given a lot of soul searching to these kinds of critiques, reflecting on what he was doing. And he said, no matter how pure our motives are, we really have to think hard about what we're doing when we risk the health of someone, no matter, what the goal may be. Well, how did those objections get answered? And they actually set the framework for thinking about organ transplantation in the United States for many, many decades. First, people argued that living donation of this kind was voluntary. No one was pressuring you, coercing you, making you do anything. So part of the answer to the question about the risk and would you take risks to help another became, well, if it was your choice to do it. And by the way, that's a situation that exists sometimes when you're a fireman or a policeman. You may face risks, or a soldier, that you're going to help others. You choose to do it. You can get into arguments about whether that makes drafts and mandatory conscription into the armed forces unethical, but that's another talk, another day. At least here, voluntary choice. And it seemed pretty clear that the twin brother had volunteered. He never expressed any regrets or doubts, fears. He had done it because he loved his brother and he was happy to do it. Second, no money was transferred to the brother who donated to incentivize him. So while it is true that transplant surgeons got paid, it wasn't quite the same as saying, I'm going to do something very risky that won't benefit me in any way to help somebody else. That actually made it a little easier to accept the idea of living donation of organs. Third, people began to say, look, different social scientists, different theologians began to say there is a benefit to the donor. You save your brother. It may not be physical, but it's psychosocial. You are emotionally happy that your brother is still here. And if you save their life, that counts not just for them, but for you. You benefit too. That framework, voluntary, altruistic choice, became the overarching ethics framework for organ transplant, first in the US and then later around the world. It meant that when somebody said, I want to be a living donor, and I'll tell you why it was all living donors for a long time and just kidneys, then you had to really make sure they were competent, not coerced, and were making a free choice to do it, which we still do these days. When someone says, do you want to donate bone marrow? Do you want to donate a kidney? We ask not the same questions, but with the same motivation to try and make sure that you're volunteering. No money is allowed. We don't pay people to donate organs. There's no market. You may wonder why we haven't tried over the years to incentivize more people to give organs. The answer is it raises this ethics problem, both about the doctor harming someone for money, and does it give the wrong incentive to the potential source of the organ so that they're not really making a truly voluntary choice in light of the risks they may face. They're just going to be, if you will, overwhelmed by the monetary incentive and not really make a free choice. If they're poor, they're going to be exploited if they're very, very poor. So we don't and have not allowed payment in this area. Unanswered questions, which have subsequently arisen. One is, what about the right to privacy of all this? When I talked to you in a minute about the use of a kidney in Boston at pretty much the same hospital, at least one just down the street, to try and save a gentleman's life. There was a ton of publicity. It just happened last week. Everybody knows, saw pictures of the recipients, saw pictures of the doctors. Everybody knew everything. But is that right? Should we do better to protect the privacy of people involved in transplants? The donors may have to know the recipients if they're living donors, but if it's a cadaver source, someone who died and they give up their organs, they don't have to. Think about the difference in the press coverage between the pig transplant that was done in Boston a week ago and Princess Kate, who's got cancer, and she announced it, not the medical team. And she hasn't really told us any details. And we've seen her maybe twice. Even less publicity for the king. We don't know what's going on with him really, other than he went to the hospital with cancer, and that's been about the end of that. Should donors, should recipients of transplants merit the same privacy? Now, some may say, I don't care. Put me on TV. I'm happy to talk about my face transplant or whatever it is. But I can tell you firsthand, having been in the field a long time, there are many people who do want privacy and don't really like all the attention and don't want it. So that was never addressed early on. Murray's procedure got attention way back in 1954, but nobody even thought about it. It was just like, this is a medical breakthrough, and the press is welcome to write about it, and the people want to be interviewed, and everybody's happy, and sort of that. So that never got settled. Pretty soon, you faced a couple of other challenges that required some engineering solutions. First, what about people who weren't twins? This procedure couldn't go anywhere if the only people who could do it were biologically identical. It was a pretty limited base for advancing transplant. So they wanted to start to use people who weren't related, strangers. Those could be people who had emotional ties to the person, spouse, in-law, friend, church member, business associate. None of those people could be used because they didn't really know, A, how to tissue type them to see if their immune systems were similar. They're not going to be identical, but similar. even blood typing was pretty crude at that point. Not nothing, but it was crude, and they knew they had to get close on blood type matches to make this work. And so one area that they needed some engineering was coming up with tools and tests to try and do antibody matching. Well, as it happened, a man named Peter Medawar in England and others came up with systems. I'm not going to go into the details to do the antibody matching, and that was a crucial engineering step to advance transplant beyond just living people giving to their identical twin, but now maybe using other people who were willing living sources. The other issue, by the way, on the living sources that came up at the time, you'll like this as a side ethics issue. Probably by the early 60s, we began to see a few cases where families said, I would like to use a child to donate to another child in the family. And there were requests to use people who were mentally impaired and institutionalized as donors to siblings. So those were controversial. Obviously, they're not honoring the free choice. Somebody else is making the choice for this potential donor. Many of those wound up in court, and the most famous one actually came many years later. It was called Strunk v. Strunk, a Kentucky case. Almost all of them, the courts ultimately said, we are going to permit this to happen. They understood about the inability to get choice, but the judges were very persuaded that it would be a benefit, psychosocial, to the child to save their sibling and have their sibling around later. So that argument about emotional benefit or psychological benefit to the donor really had power. I was never fully convinced, and I'm still not, about the use of people with intellectual disabilities, because I'm not sure they appreciate, some do, some don't. They're still having their sister or their mother or whoever it was still around. I think that's a little tougher if you're going to try and justify it on emotional benefit to the donor. But certainly kid to kid, courts did. So the next step in the history of all this is, how do we get organs not just from living people, but what about dead people? The surgeons were certainly well aware that they were encountering people who had terrible head injuries, brain injuries, but whose organs looked pretty good. So they were dying because their brain could not sustain them. They weren't going to think or feel. Their brain couldn't, if you will, operate as the thermostat for the rest of their body. And so they were going to withdraw life support. And even though their heart might have been working, they were going to let them die. The experiments were going on with dogs and other animals. By the way, also at the Ben Brigham Hospital, ironically, but other places too, to see whether organs that came out of cadaver dogs could save other cadaver dogs, and it looked like they could. So I told you one engineering problem was antibody matching. The second was a pharmacological engineering issue. Were there drugs that would suppress the immune system? Turned out in the 60s, people began to identify and work with steroids. And they do have that impact of tuning down the recipient or the person who takes the drug's immune system. And there were some other drugs around that also seem to have this impact. I'm not going to go into their discovery, but this is a big industry, academia collaboration. Industry is trying to develop basically drugs that will suppress the immune system. And there is some success. From today's perspective, they all look pretty crummy. But at the time, they looked pretty good. And so people were willing to try and use those. Another engineering challenge. Right now, if you're doing living donation, you got to put the donor and the recipient in the same room, because you can't be running around carrying a heart. It's going to get damaged because it doesn't have any circulation. So a huge bioengineering problem was organ preservation. That involved both chemistry and physics, like put them in a box at the right temperature. So this is another area where bioengineering and medicine closely intersect. And we all know today the pictures of the little cooler and the guy's running to the jet and he's going to fly it across the country. That's the technology I'm talking about. We didn't have that. So initially for cadaver donation, everybody, it was like this gigantic emergency. You had to get the recipient to the hospital. The donor had to be dead in the hospital where the recipient was. You had to take out the organ right away and try and insert it as fast as possible into the recipient, which didn't lead to the best outcomes. I mean, that was really pretty panicked surgery. So one thing that ethics did to help overcome this, and then we're going to go up to modern times, going to introduce one other concept. If we're going to take organs out of people when they're dying, when can we do that? It's better to take them sooner than later. People know that if someone dies, you don't want them lying there for minutes or hours. The organs are going to fail. Organs need oxygenation. Organs can't just sit there. Hearts probably fall apart 5 minutes. Kidneys a little tougher. You might get 10 minutes, but that's a pretty narrow window to do an operation in. So ethicists now exist, bioethicists, and begin to have discussions and say, well, look, the traditional definition of being dead is when your heart stops. But you are observing, doctors, that there are many, well, not many, there are some people who have terrible head injuries, and you know they can't survive, gunshots, trauma from getting hit in the head with something, pool accidents, this sort of terrible stuff. Maybe we could come up with a second way to pronounce people dead when their brains are irreversibly damaged beyond being able to function in any way. And that became the concept of brain death. Brain death was a key step forward. It wasn't engineering, it was ethics. If you accepted the idea of brain death as total irreversible loss of all brain function, I'm not talking about being in a coma, I'm talking about nothing. And we did, well, there was a technological twist here too. We began to invent, or people began to see, the introduction of equipment that could measure brain waves. And so you could start to test to see if the brain had any electrical activity of significance. That allowed, once states began to say there are two ways to be dead, heart stops irreversibly, brain stops irreversibly, then you could keep people on the new technologies of heart machines, the new technologies of respirators, these are other bioengineering steps, and remove organs while they still had circulation because their brain had stopped. So even though it may look like somebody's alive on these machines, they're not. Their brain has ceased to function. That's pronounced by a neurologist who has nothing to do with organ transplant, just says you're dead. And then organ transplant people come in, they don't disconnect, they actually remove the organs from the dead person, even though they're artificially running. And that expanded organ transplant from living donation to cadaver donation when you introduced better immunosuppression, better antibody typing, and preservation of organs, both through special fluids pumped into the organs and cold temperature transit. Now that we're in the world that we're in today, where you can see transplants done from a donor in Albany going all the way out to a recipient in Irvine, California, one I just watched recently. So just to sum up, and then we're going to move up to the new world of pigs. Transplant starts out as only living people who are biologically related. Very narrow. Even though it works, you can't really get much done. It took a whole series of ethics steps to make it ethically acceptable to remove organs from living people. And we set the framework ethically of voluntary altruistic donation. That was then extended, by the way, to cadaver donation, voluntary altruistic donation by next of kin, or you could do it by a donor card, or today, many of you know you can register at motor vehicles and put your name in and say, I want to be an organ donor when I die. I have a joke about that, by the way. I've done that a couple times in New York and Connecticut, where I live now. If you try to register to be an organ donor at motor vehicles, there's a pretty good chance you're going to be an organ donor, because it takes about 90 years to get through motor vehicles. So there's a pretty good chance you'll be dead there before you actually complete the registration. But anyway, moving along. So we extend living donation. We now have a cadaver system. And I've tried, just because you guys are all interested in engineering, to show you that this entire field is intimately connected to bioengineering steps, whether it's the antibody system identification, whether it's the ability to keep a brain dead body going with heart machines, artificial ventilation, and by the way, I didn't even get into it, but other blood pressure maintenance and other tools that you need, the ability to diagnose brain death using bioengineered equipment that lets you measure the brain. It goes on and on. This, people don't think about it, but in my experience around healthcare, this is one of the areas where there has been a 50-year marriage between bioengineers and surgeons and transplant specialists. It's just, you can't make these steps unless you work these problems. Nonetheless, today we enjoy a lot of success. A lot of people want organ transplants. So you've expanded past kidneys. We can now preserve the heart from brain dead people. So heart transplant appears, liver transplant appears, even lung transplant. And we see probably waiting lists in the US today of about 100,000 people, most of whom are going to die because there's no organ to give them. The only way we get organs is from a living donor, and we use a lot of kidneys from living donors, but not enough living donors are out there. Relatives do it, friends do it, but strangers don't generally just show up and say, I'll donate a kidney to Art. I don't know exactly who the hell he is, but I'll give him my kidney. You don't get much of that. And cadaver donation can't go on unless we all agree to be organ donors when we die, which in my opinion, you should, but we don't. So we are way short. And I would tell you that every day in the US, about 12 to 15 people die on the wait list, no organ. And the problem is worse for children, because there are even fewer organ donors, cadaver organ donors, who are children. They don't drive cars. They're not around weapons. They're just a much smaller pool, happily, of organ donation from adolescents and young kids and babies. So there, the wait lists are crazy. So what are we going to do about that? Now, we can, Azita, pull up the Xeno slides. What we're going to do is look for other sources of organs. And that's where people have begun to think about using animals as potential sources. I don't like that choice. It raises its own biological obstacles, because animals are even further biologically away from us than strangers between humans. So that makes it tough to conquer those differences. You'll see, we'll just give Azita a minute here to punch that thing up. And where she's going here, well, we wait. The original efforts to think about animals were done, again, way back in the 60s. People even then were thinking, well, living donation, we're still putting some people through giving up an organ. That isn't great, even if they choose to do it, even if they benefit from saving someone. Wouldn't it be better not to have to take organs like kidneys out of living people? Maybe we could use animals. So early efforts started in the 60s by people like Keith Reemsma, who was then at Tulane, but later moved to Columbia, to try and use chimps and baboons. And those early efforts ran into, again, significant engineering problems. For one thing, the primitive immunosuppressive drugs that they were trying to use in people did not do the job in animals. And so you had a lot of rejection because we didn't have powerful enough immunosuppressive drugs to conquer the gap between chimps and us. Another problem was purely physiological. You didn't have enough size in chimps and baboons to support adult human beings. They're too small. Another problem was they also don't breed very fast. And so if you needed or were hoping to get a supply of organs, it was hard to get chimps and baboons. Chimps, very difficult, very almost going extinct even at that time. You didn't have animal farms to handle them. And baboons are ornery and running around in the wild, and again, difficult to manage. So early efforts at animal experimentation fell apart, mainly due to the challenge of having the right drugs. So keep going, Azita, keep going. This is the failures that I'm showing you here. Tulane gave up in 65. Go to the next one. Tom Starzl, famous heart transplant surgeon, tried. Even efforts in the 80s, Baby Faye looking for organs for kids was a procedure attempted at Loma Linda with a baboon heart to try and save a baby born with a completely malformed heart. Didn't work. The baby died about a half year later. Rejection again, couldn't really get over the blood type difference between the baboon heart and the antibody difference. Didn't work. Next one. So there weren't other options. That's why they were thinking about chimps and baboons. The more transplants started to succeed, the more cadaver transplants started to work. People were like, we don't have enough donors. We don't have enough donors. What are we going to do? They did redouble their efforts to try and make people think about organ donation when they died, but a lot of people were nervous about it or didn't want to do it, fearful that maybe their funeral might be impacted and this sort of thing, which it isn't, but they were worried about it. And then as the experiments went on in the 80s, we began to see a more vigorous animal rights movement start to say it's wrong to kill primates, even if you're trying to save babies. We don't accept that they're a good source of organs. Let's look at the next one. So that takes us up from a long history of failure up to the present day, where you see people starting to use a new animal, the pig. Why pigs? Well, pigs are physiologically, I hate to say this, I'm not trying to insult any of you, but they're closer to us in terms of size than these primates. So a pig is a little bit physiologically like a human being, horizontal. 300 pounds, 400 pounds, they can support adults. Their organs are the same, roughly the same size. You've got a pretty good chance of being able to use their organs. Secondly, a new technology has appeared. There's a bioengineering solution. We map the genome of humanity. You all know that. We understand a lot more now about the human genome, but we've also been mapping animals, dogs, pigs, many other species. And we've mapped pigs' genomes to the point where we know which genes control their immune system. So another technique, in addition to mapping the genome, comes CRISPR, which I won't go into in any detail now, but it's basically being able to use a molecular scissor, take out a series of genes, and insert another set of genes. That's what they're doing with these pigs. They're taking out the pig genome area responsible for immunity and putting in human genes to make the difference between their organs and us less. So they never really solved the problem just trying to do immunosuppression. That's why all those prior animal experiments didn't work. But once we could do genetic engineering, and once we had a map of the genome, we opened the door to the possibility of using a genetically altered pig to be a source of organs for humans. We do it at NYU. There's a slide up there, and I'm going to tell you about that in a minute. Efforts have been made to put a heart into a human patient at the University of Maryland. By the way, didn't work successfully. And last week I mentioned, or 2 weeks ago now, an effort was made to put a pig kidney into a 57-year-old recipient back in Boston, this time at the Mass General, using a genetically engineered pig as well. Well, issues that come up still with pig transplants. If you go backwards one slide, if you can do that, Azita. Notice here on this slide at NYU, it says surgeons put a genetically altered pig kidney into a deceased patient. So our experiment, the first one, which led to the Mass General Boston attempt to put a pig kidney into a living person in need, the reason we tried it this way was I came up with the idea, why don't we test some of these animal organs in people who are brain dead? We have accepted brain death as the definition of death. That we're using brain dead people as sources of organs. But why not use them, I thought to myself, as a way to test organ transplants? And there was a lot of discussion about whether it would be ethical to do that. Whose permission do we need to say you're brain dead? We decided if you'd signed up to be an organ donor, but say you had cancer and you couldn't be an organ donor because you transmit the cancer, maybe that would be enough to say, still, I'd like to contribute to transplant research. And then we'll go to the next of kin and ask them. So we only use people who've signed donor cards and whose family consents to their body being used as a way to test genetically altered pig organs in those bodies, usually for a week. And then we stop so that the family can have a funeral and come to terms with the loss of their loved one. But some families have permitted us to go out as long as 2 weeks. The people in Boston could approach the kidney transplant with more confidence because they knew NYU had studied this a couple of times in brain dead people. The kidneys produced urine, they didn't reject right away. So I'm giving you this as an example. Ethics does not always run around saying no to things. This was an area where I said we got to go faster to get animal parts. And one way to do it is to do something that had never been done, which is to study surgery in a brain dead person. Now, it's not beyond controversy, and I'm happy to answer questions about that later, but it worked. And that model is being used to study pig heart transplants, pig kidney transplants, and I will tell you down the road, I am sure it is going to be used to study other interventions like new gene therapies, like new risky drugs. You can study them first in a person who's dead but whose body's maintained artificially on life support and see initially what the impact is of your experimental intervention on a human body. That makes it less risky to try it in a real person in need for the first time. So it's a bridge, if you will, from doing it in animals, maybe trying it in a few brain dead subjects, and then trying it for the first time in a human recipient. You can shut the slides off now, Azita. I'm going to tell you a couple more things about pig organs and some of the issues that have come up there. So the issue about animal welfare and animal rights is still here. Pigs are not quite as smart as chimps, but they're pretty smart and sentient. And they certainly can suffer, and they certainly have cognitive skills. I'm not a pig expert, but I know that their mental abilities are higher than many other animals. You may be thinking, well, it would be inhumane to just kill pigs to get parts. First, I think it is humane and ethical to sacrifice pigs to save humans. But you have to treat the animals, the pigs, super well. Now, the genetic engineering doesn't do anything to harm them. It doesn't hurt them to change their immune system. But you may be relieved to know that these pigs are the happiest pigs on earth because they get well fed. They're in absolutely sterile environments. They get tons of exercise. You want them to be in the best shape possible to donate a kidney or a heart. So this is not factory farming. This is not squeezing many animals into pens and giving them lousy food to get pork chops. This is really trying to make sure you've got the best, healthiest animal out there. Animal suffering is really to a minimum. In terms of donating a kidney, you probably don't even have to end the life of the pig. You can remove its kidney, and now we have the technology to ship it and move it and all that. So you're probably going to need thousands of pigs, if it worked, to bridge the gap to the waiting list that humans have. 2 billion pigs die each year for food. If your concern really is pig welfare, then I would argue too, the best place to go is to protest the use of pigs for food. And there are alternatives to them, plants and other animals, fish, lower order animals we could eat. But I think that's where the animal welfare movement should be. Healthy pigs that don't suffer, saving humans, to me, is a moral equation I'll defend. The other issue about xenografts or pig organs might be, would everybody accept them? There are major religions, Muslim tradition, Jewish tradition, you're not supposed to eat pork. So I have pulled together some advisors from these religious traditions. I don't have every single religious expert surveyed, but I've talked to enough to know this. No religion has objections to using pigs if they save lives. You can override the prohibition against eating pork if the goal is to surgically use an animal organ to save your life. So they'll give that higher priority than respecting the prohibition against eating pork. Moreover, many of those, not all, but many of the religious leaders say, you know what? I'm not even sure the prohibition applies because you're not eating it. You're putting it in surgically. And we've had many operations over the years where pig valves from their hearts have been put into humans to replace defective valves in human hearts. And no religion has ever jumped up and said, we can't do that. So I think that objection is also not going to stop us. It's going to be whether this works. Does the genetic engineering prevent rejection? Do the better immunosuppressive drugs we now have also help prevent rejection of these organs? If you're putting them in younger people, do they grow normally? We don't know that. No one's ever seen that. And even you could argue a little bit, and then I'll turn this over for some questions or comments. What would constitute success? If I just keep a guy alive with a pig heart, but he never gets out of bed, and he can't really talk much, and he has no energy, and he's completely fatigued, I don't consider that a success. You have to have some quality of life, some meaningful survival time. Those are the measures. So when the press says successful kidney transplant from pig done last week, it's not successful yet. I mean, the operation, great. But the total outcome of using pigs remains to be seen. They're not living, let's say this guy dies in 30 days from rejection. Does anybody say it's a success? I wouldn't. You're probably looking at minimum 2 years, ability to go home, ability to have some enjoyment in your life. I'm not saying you have to run marathons or climb mountains, but sit up, walk around, maintain activities in your home that make you be a little bit independent, enjoy your food, be able to go out to a concert, this sort of stuff, whatever the particular person values. And that's where we're measuring success, really. It isn't just, I did this operation and nobody's dead at the end of the operation. That's a step towards success, but in my opinion, is not success. So let me stop there and we'll see if you all have any questions about the history, the framework that's been created to deal with human organ transplant, why we're thinking about animals, why pigs, efforts to try to use primates that failed. Anything you want to ask is fine.
So our first question is, please address the risks of xenotransplantation regarding unpredictable infections, maybe tied to potential for Jacob-Creutzfeldt when harvesting pituitaries for growth hormones, and the ethical justifications for using other species to solve human problems that humans could solve otherwise, example with universal donation.
So let's do the last one first. It is absolutely true. We could solve the shortage. All of us just have to donate more organs when we die. And I've tried over the years to come up with many ideas. Instead of asking people, do you want to be an organ donor? I've proposed many times that we presume you're going to be an organ donor. And if you don't want to do it, you have to carry a card to get out of it. I wouldn't make you do it, but I'm perfectly happy to say, instead of asking people to opt in and become organ donors, we should ask them to opt out and say, I don't want to be an organ donor when they go to motor vehicles, or they could carry a card that says not me. I think you'd get a lot more organs that way if we shifted public policy. Some countries have done so, and they do get more organs. In Austria, Britain is now flipping to this just in the past year. It's called presumed consent. I first called for this, I think, in 1986. So I think we could do more, and we should do more. But until we do more, we have dead people. So we had to do something. It would be my argument. But if you don't like the use of animals, then make sure you and your friends sign donor cards. There's nothing to stop that, and we could make laws more welcoming to encourage cadaver donation. In terms of viruses, prions, pigs could transmit, animals do transmit all kinds of diseases to us. Swine flu, avian flu, there are a bunch of them. And pigs have their own viruses, by the way, that they often give to each other, causing tremendous problems for the meat industry, where they have to kill a bunch of animals because they are infected with various pig microbes that they're transmitting to other pigs. So there is a worry that if you put pig organs into people, they will carry along hidden viruses and maybe infect the recipient or the people who come in contact with the recipient. So I think you're going to have to see the early days with only people doing this who have labs that can detect and screen for these viruses. It's been a criticism I've had of Maryland. I'm not sure what their capacity was in their heart transplants that they've done twice. And you may want to have quarantine for at least the first 60 days to see what's going on. Is anybody getting infected? You certainly want to have protection for all the people that have to scrub in to do the operation, the nurses who have to do the aftercare. So I would be cautious. Many of the genetically engineered pig companies say they think they've also hit the sites that would turn off the viruses, but I am skeptical that we know that yet. So I do think there's a need for caution.
Thank you. What do you think are adequate neurological measures or evidence for brain death of humans that is adequate for experimentation?
So the trigger for experimentation is absolutely the same as the trigger for organ donation. They're not different criteria. You need to be pronounced dead. Nobody is going to be experimented on who an independent neurologist has not declared dead. In other words, I'm not having doctors show up and say, I'd like to experiment on this body. I think it's dead enough. Determination of death is by independent people who are just treating the patient and say they're dead. Now that has to happen anyway, because they're going to disconnect life support. People are going to start to ask questions about autopsy sometimes. In other words, a number of things happen post a determination of death. I'm adding experimentation to the list, and that would only be if you volunteered, if the family consented rather, and if you had a donor card that said, I'm willing to be involved. Ultimately, I'd like to change the law to make sure that being available for research as a brain dead person after death was on the donor card, because you could say no to that if you didn't want to do it. I'm not trying to force anybody into this. Neurological criteria are very well established and very well known. Brain death is pronounced all the time. There's some nervousness that maybe with better technology like MRIs, maybe we could see things in the brain going on that we can't quite see with our EEG machines, testing reflexes and so on. It could be, but that isn't an issue for research on the newly dead. That's an issue about upgrading technology to pronounce death. Sadly, if people thought there might be echoes of activity somehow, using technologies like MRI would probably be too expensive. Most hospitals don't have it. I'm not sure you could do it. On the other hand, you're not going to keep people in an ICU running up a bill and denying resources to others because you don't have an MRI. So there's always a little bit of uncertainty about, could you have had brain activity for a couple of hours, maybe another day. It's not like you're going to wake up all of a sudden and surprise everybody. The brain death criteria are not that far off, but there could be people who aren't totally loss of brain function, but we can't quite detect it, but we know where they're going. It's not like somehow we're killing or allowing to die people that otherwise would have come back. By the way, the same is true in heart. You don't think of it this way necessarily, but when somebody says, thinking of the medical shows, somebody has a heart attack, they go into heart attack arrest, they try to resuscitate them. Guess who decides when that's enough resuscitation? The attending doctor. There's no test that says, oh, that heart might have beaten for another 6 hours. You try to shock them with the pads or heart massage them or do whatever you're going to do. And then you say, doesn't look like they're coming back. And that's how cardiac death gets pronounced. So brain death is actually a better protection, more definitive than heart death.
So around that, there is another question, and I just wanted to make sure that we have everything. There is an active conversation around the definition of brain death. What is your perspective? So is MRI really the way to go, and that is too expensive?
Too expensive, not needed. I think the tests that we use now, no reflexes, inability to breathe off the ventilator, 2 tests over 12 hours, scanning for organized brain activity. I don't worry about misdiagnosing death. You occasionally get people, family members, who think coma is death, permanent vegetative state, where there is brain activity, at least in the cerebrum. And they say, oh, they told us they were dead, but they're still breathing and they're still here. That's misunderstanding what the doctors are saying. Sometimes they hear that as dead. They're not dead. That's just somebody who's in a permanent coma. Now, you still can get into an argument about whether you want to treat them or whether you should let them go if they can't ever think or feel, but they most certainly have organized brain activity in a vegetative state, but that's not the same as brain death.
Great, thank you so much. And another comment and question. Thanks for this talk, Dr. Kaplan. Do you think we could have generic guidelines about what counts as success, or will it be idiosyncratic based on individual values?
Yeah, good question. So to get these procedures, let's say the animal ones, approved, or novel procedures like face transplant, where you're moving a face from a deceased person to a person who's had a terrible injury, hand transplant, uterus transplants, you may have heard around. The FDA is going to give approval and say, enough research has been done. These are now therapies. But the FDA doesn't really answer the question of how good does it have to be. You know who answers it? The payers, insurance companies. VA, private insurance, Medicare, Department of Defense will all have a role in saying that quality of life is sufficient for us to pay for it. So it's one thing for the regulator to say the science looks pretty good, doesn't look like things are going haywire after 9 months. Okay, you can do more. But it's really in the US, we don't form too many commissions about what's the right metrics to say it's a success. For reasons beyond me, we leave it to the people who pay for the procedures. So you can get different answers. The VA may say, we like face transplant because our veterans, we want to help them and we owe them. And a private insurance company may say, you call us up when somebody's lived with a pig heart for 2 years and gone back to work or something like that.
You talked about a series of stakeholders here. So if you were to kind of prioritize them, who would you say has the most power in making these kinds of decisions? Does it depend case by case, or in general, can we say that it is the insurance companies, for example, that have, or the doctors?
It used to be the doctors working with the FDA. As prices of these procedures have gone up, and a face transplant is probably 2 million to 3 million an effort. Pig transplants are certainly in the area, given the genetic engineering and all that. I bet they're 1 million. It's the payers. They're started to have more and more authority, just like you can start to see them have authority over things like injectable weight loss drugs. $1,000 a month. You can figure with a couple of doctor visits, they're $15,000 a year. You're going to stay on them for a long time. For obesity or weight management. I've already seen 2 programs this month, state Medicaid programs, saying we can't afford it, we're not paying.
Great, thank you so much. Why can't we have organ donors listed as a default that people can opt out of, as they do in parts of Europe?
We can. That's presumed consent. I'm all for that. I think I was one of the early proponents of that. That's where I said, I think I wrote the first article in favor of presuming donation with an opt-out in 1986. So yes, I think you're not stepping on informed consent or choice. It's just coming with a different valence. You can say everybody has to choose to be one. You can say everybody has to choose not to be one. But we know by nudging people in the direction psychologically that it's a good thing to do, and we presume you want to do it, that we'll get more than if we flip it to it's a heroic thing to do, and you probably haven't thought about it much, but maybe you do it. So I agree with that.
We have one more question. I know we've gone over time. If you don't mind, maybe pose this question as well, if you don't mind.
Okay.
The last question is, how far off is the technology to grow organs in the lab?
Pretty far off, sadly. What isn't far off is regenerative medicine, using your own cells to make, let's call it just strips of tissue like skin, or simpler systems like a bladder, which you might be able to grow around a plastic matrix, or maybe an esophageal windpipe. Organs are pretty complex. Kidneys have all kinds of parts, specialized cells. The liver is a mess. It does all kinds of digestive things, excretion things. Growing that, regenerating it is harder. So you're going to see regenerative tissues start to appear, maybe blood, maybe things like saliva, maybe things like bladders, maybe even a uterus, maybe. But really regenerating organs, I think that's the long-term answer, particularly if you can grow them back from your own stem cells. You don't have immunosuppression problems. It's like back to donating to your twin. But from an industry perspective, organ manufacture, even thinking about printers, 3D printers and stuff, I'm going to say 10 years, 15 years. I think we're stuck with the pig option for a while.
Great. Thank you so much for spending this time with us. And on behalf of the OEC, and we have a director of OEC, Dr. Rosalind Byrne, our coordinator, I thank her again. And thank you so much again for spending your time. And our coordinator, Tracy Marshalls, and to all of you who joined us this afternoon here in the East Coast Really appreciate this time, and we may ask you to come back if you don't mind. Thanks so much.
Thanks,
Enjoy the rest.
everybody.
Bye-bye.